So I got an email from Chris Leto the other day. I was on his channel recently. You should check his stuff out. He's got all kinds of cool videos. Anyways, he was super awesome. I enjoyed going on there. But his email was about the solar limb anomaly, which is another fascinating topic. It made me think of the Pioneer anomaly. Like, there's all kinds of little things like that in astrophysics. With each one of them, though, the complexity is just overwhelming. There's the number of variables that are involved in something like that. They're basically directly proportional to the popularity of whatever anomaly you're discussing. As more and more stuff is published, people always find new ways to add more and more layers of complexity. That stuff, this sort of thing, on the smaller scales, it's fascinating. Don't get me wrong. It's all important and interesting. This is the stuff that can help me validate what I'm saying about the bigger scale, whether or not the universe is expanding. But they're not really convincing for the big picture. You can use them as evidence, but they're not really powerful. They're just too complicated. Of course, all of my claims are pretty complicated too, but they're really not. And if you can grasp my main points, then you don't really need all that other stuff. Hopefully, you'll understand what I mean by that here in just a second. But I mean, it may take some work on your part to believe any of these, but to believe this. But the main points that I want to make, my primary claims, except for, of course, the interpretation, but my main claims have already been validated and accepted by the consensus of physics, and they're fairly basic, fundamental concepts. But that's why I wanted to make this video. I wanted to clearly lay out what my claims are, so they can be tackled. All of my other videos are pretty old, and I don't know. There's no telling what I said in those or how accurate I was with my language back then. But my biggest proposal, of course, is that the cosmological redshift is caused by gravitational redshift and not expansion. But this is just my interpretation. I mean, it's just a hypothesis. It's not really supported by a large body of evidence or legacy cosmologists or anything else for that matter. My main reasoning comes from three simple postulates, and these are supported by the consensus and by the legacy cosmologists. These shouldn't be considered my main points, okay? These are actually my true claims. All the other stuff is just attributed to these three postulates. The first postulate is that symmetry manifests at scale, okay? Now, I'll go over all of these here in just a moment, but the second one is Birkhoff's theorem manifests with symmetry, and the third is that the structure of the universe is hierarchical. I have rho equals r divided by r, just show that the inverse proportionality of mass density to the radius of the chosen volume. Now, if you can accept these postulates, then you must also come to the conclusion that the universe is not expanding. I mean, not necessarily. Don't get me wrong, it's still possible that the universe is expanding, and these three postulates are true. That's not really the point. It's physically possible. There's just no reason to make that assumption with these three postulates. The universe is a pretty big region. There's all kinds of things going on. There's explosions and collapses, and regions are doing different things. But to talk about the entire universe expanding, that's an isotropy that I'm not. It doesn't make sense to me. But anyways, if you can comprehend any of this stuff, you really don't need too much else except for these three postulates to come to the conclusions that I've come to. Just a general understanding of the structure of our universe should be enough to get you there. Let me briefly walk you through these three proposals. These images here are from the Max Planck Institute. These are some of my favorite images of all time. These images clearly demonstrate how symmetry manifests at scale. I'll just let the images speak for themselves. You can see how the universe smooths out the larger the scale that you're talking about. With this image, this is a cloud of dust with an emitter in the center. Okay, this is a good demonstration of Birkhoff's theorem. So, if you have a perfectly symmetrical sphere of dust, in the dust cloud, it doesn't matter where the emitter is located. So long as the observer is located on the outside of the dust cloud, the emitter will appear as though it is coming from the center. As far as gravitational redshift is concerned, the emitter will appear wherever it appears, but the amount of gravitational redshift will be as if the emitter is in the center. And that is the basic gist of Birkhoff's theorem. This image, there's the Earth and the Sun and a large cloud of dust around the Sun. If we're on Earth observing the Sun's light, the amount of gravitational redshift will be determined by the amount of mass in both the cloud and the mass of the star. It's as if all of the mass was located at the very center of the star. And that's how much gravitational redshift would be. In other words, there wouldn't be a gravitational blue shift for the dust on the Earth side. It would all go towards the star, because that's Birkhoff's theorem. Now, of course, these are all idealized situations. They're just useful for describing these fundamental relationships. In the real universe, things are a lot trickier. Symmetry is required for Birkhoff's theorem. That's why the nature of scale is important. Now, the reason that cosmologists assume the universe is expanding has mostly to do with the way the field developed in the early years. Okay, when Einstein was working on general relativity, he realized that the universe he created was not stable. It was going to collapse. I mean, due to its own gravity. If you just put a bunch of mass in one area and nothing else, gravity collapses. The cosmological constant was added to prevent this. There was, lots of back and forth about Einstein's work during this time. Several others came to this conclusion that the universe could be expanding, and that it was around the same time that Hubble discovered the cosmological redshift. But in those days, they were really surprised to find that there were other galaxies outside of our own. Like, they didn't know exactly how the universe was structured even then. And then at some point, academic journals just stopped publishing anything outside of the expanding paradigm. But we really didn't know the true scale of the universe for a long time. And I think we're still off on the true scale. But regardless, all of this sounds complicated, but this is not really complicated. Okay, symmetry manifests at scale Birkhoff's theorem is applicable with symmetry, and the structure of the universe is hierarchical. That's a hard word to say. Hierarchical. About any word is hard for me to say. But if you can accept these three postulates, I don't know how you can't come to the same conclusion that there is also a gravitational redshift that is directly proportional to the distance of light travel, okay? For observers, at least for observers uphill from stars, the gravitational redshift is going to be proportional to how far it travels. If you were to talk to one of these cosmologists, one of the big shots, or a professor that understood this stuff really well, if they understand it really well, they would tell you I'm wrong because the universe is expanding. They believe that there is no gravitational redshift except from bodies like stars and galaxies and maybe clusters, and maybe a few other larger scales have been published. But they think that all of these objects are gravitationally disconnected because, of course, the universe is expanding. And so that's enough. Let's go back to this image. I think I have a video that I'm going to play, but I'm looking at the image. But does this look like an expanding universe to you? I mean, it's silly, really. It's silly. When I say the universe is hierarchical, I mean that the stars are embedded in galaxies, and that galaxies are embedded in clusters, and these clusters are embedded in things you would call a supercluster. And then superclusters are embedded in what you would call filaments. And these filaments form veins and a web that's embedded inside the observable universe. And I'll just leave you with the following question, okay? If the universe were exactly the same as it is now, but it's static and infinite in all directions in space and time, would there still be an observable limit due to gravitational redshift? And if so, what is it? So I asked ChatGPT, and ChatGPT is usually pretty bad at this stuff. I mean, it can be okay if it's coached correctly, and it's definitely somewhat helpful. But I asked it, and it provided a great response. I'll leave a link in the description below. You can also check out my website if you want some further reading. My messaging, even on my website, is outdated. The messaging of this has always been the issue, and so that's why I wanted to lay out these claims so that if anybody knew cosmologists or whatever and they wanted to discuss it with them, then this would be a great place to start. Thank you so much for listening. I love you guys. Y'all have a great day.